Have you ever started a project knowing exactly what you want the end result to be, but simultaneously not knowing exactly how you're going to get there? Well, let me take you on a journey. I have this old angle plate kicking around, and I need it for a certain setup. Hold your horses, we'll get to that setup in a bit. But right now this angle plate is in no state to serve as a square reference that I need. Off the cuff, this seems like a pretty simple cleanup job. Heck, the general shape and features are already there. But the more I think about how to hold and indicate such an oddly shaped part, the less certain I am of how I'll actually manage it. So let's go on a little adventure and see what I can come up with. I'm not sure the origin of this angle plate, but one thing is certain, it needs some TLC. Not only is this rust obscene, the slots already on this plate are all jagged and uneven. And I'd be extremely surprised if this is even remotely close to square. First things first, let's remove all the rust. The quick way to do this would be to sandblast the entire part. While this would certainly work, something is telling me I'll create more trouble for myself down the road if I induce a bunch of surface stress on the part. So I'll take the slow approach and give this a bath in evaporust. A few hours later, after picking away at some other side projects, it looks like just about all the rust is dissolved. I'll give this a good scrub down with some Scotch-Brite pads, and then clean it all up with some brake cleaner. Now I'm really curious to see what I'm actually working with squareness-wise, so let's check it out. The surface gauge I made in a previous video is a perfect squareness comparator. I'll set the 0 with a reference square, then move over to the plate. Well now, that's actually really close, within a few tenths over 3 inches. Of course it's worse where some of the caked on rust still exists, but this is a promising starting point. One last thing before digging into the machining is to measure all the slot positions. I mentioned before that these are all fairly jagged and unevenly spaced, so I'm going to trace these out with an end mill and make them look nicer. And while I'm at it, enlarge them to fit my 1/2 inch hold down hardware. Over on the mill I'll set up for the first cuts. Resting the far end against the parallel ensures the base is parallel to the cutting plane. Then clamping with the 246 block against the fixed jaw maximizes the clamping surface area, while also helping minimize chatter. Now I can take a skim pass with a face mill cutter and bring it in true. My thinking is this will give a good reference to seat against when I mount the part with the large faces up for fly cutting and slot milling. I don't know why it didn't dawn on me until just now, but this is cast iron I'm working with. This makes me even more excited for the quality of the finished plate, since cast iron will be a lot more stable than steel. To mount the angle plate for the remaining operations, I'll need a nice square 246 block. And the one I have is not nice. I don't know about you, but I've been itching for a good side project. I'll start like I did with the angle plate and give this a bath in some evaporust. And might as well do my other one while I'm at it. A light scouring with Scotch-Brite and we're looking pretty good. Now one would assume that a manufactured 246 block like this would be pretty close to square, but something in the back of my mind is telling me to check if that's actually true. Well, it's not just a little off, it's way off. Nearly 2 thousandths across 3 inches. If I'm going to use this with any degree of accuracy, I'm going to have to grind it in square. Oddly enough, all the outside dimensions are 2 thou larger than they should be. I wonder if these blocks were intended to be ground in by the final user, or somehow they jumped in line at the manufacturing plant. Either way, I'm going to have to grind this in square with the remaining 2 thou I have left. To start, I'll clean up the large faces on the surface grinder. There's a bit of rust pitting, so I'm hopeful that I can clear this up without going below the 2-inch thickness that makes this a 246 block. After clearing the first side, I'll flip this and repeat it on the opposite. This ensures that the 2 faces are parallel, and then we can set the other 4 faces square to these. Back over to the surface plate to take some measurements. Setting the surface gauge with a 2-inch gauge block, I'll move over to the 246 block and check the thickness. I'm about a 1/2 thou shy. So much for not going below 2 inches. But what's more important for me is the squareness of this block. I'm pretty consistently getting a lean of 15 tenths over 3 inches in this direction. To fix this, I'm going to grind a very accurate step directly onto the part to get it to lean back up vertically. This is referred to as the step method for obvious reasons. First is to clear the top face, making it flat and parallel to the bottom. This block is leaning 15 tenths over 3 inches, which converts to 2 tenths over 2 inches. So I'll grind this face that extra 2 tenths, leaving just a sliver untouched on the appropriate edge. About like that, and don't ask about that burn mark. Just to verify my work, I'll set this back up step side down on the surface plate and check it with the comparator. If I've done it right, this face should now show no deviation. Now that's what I'm talking about. I'll set this back up step side down on the chuck and grind the top face square. Then flip it one more time and grind the stepped face square as well. This takes care of 4 of the 6 faces, but the last 2 are a little more involved since they have to be square in 2 directions rather than just 1. Fortunately, the process is pretty much the same. Grinding a correction step for one direction on the first face, flip and grind a correction step in the other direction for the other face, flip again and grind the first face clear, which is now square in both directions, then flip one final time to grind the last face square in parallel to all the others. Then it's to the surface plate to see how it came out. I'm still a tenth or so out of square in a couple areas, and while I'm very tempted to chase down these zeros, I think I might end up spending a week just to get there. And this little side project has already turned out to be more than I bargained for. I still have a second 246 block to do, but in the interest of time I'll shelve that for now. I have an angle plate to finish first. With my 246 block now mostly square, I can bolt the angle plate to it, which will let me use the block faces as my indicating references. As I'm mounting the angle plate, I'm also using a squareness comparator to ensure that the plate is starting somewhat parallel to the 246 block. When I clamp this in the mill vise, I can position the 246 block against the base and the fixed jaw. This gives me reasonably good confidence that the coming operations will be square to the mounting face. I suspect this cantilevered area will make quite a racket when I start machining, so to hopefully reduce the vibration, I'll use this makeshift machinist jack to support the free end. A dial indicator helps make sure I'm not deflecting the material out of square. This first face is the one with all the residual rust, so to start I think I'll fly cut this smooth. It's a pretty wide face though, so I'll have to use a clever trick I tried once before and fly cut this with a boring head. I had some pretty good luck doing this on some aluminum previously, but it looks like that luck is run dry. The combination of cutting over the slots and the boring head not really being intended for this resulted in the finish even worse than before. Luckily I'll be grinding this face, so I should be able to correct this mess. Before I get to that though, I want to do something about these slots. Like I mentioned before, they're all wonky and I'd like to enlarge them to be compatible with my half-inch mounting hardware. I already recorded the location measurements of all the slots, so the first step is to locate the part with an edge finder. All of my measurements reference this corner, so I'll zero my DRO here. In my experience, milling a half-inch slot with a half-inch end mill will result in a slot slightly wider than a half-inch. Rummaging around in my end mills though, I discovered an undersized half-inch mill at 0.475. So I'll run this on centerline for the first pass through the slot. Then run a 12.5 thou offset pass along each side to take it to width. I mentioned before that I had heard machining cast iron is fun, and now I see why. It just seems to cut so smoothly compared to steel, almost like cutting chalk. And something about it is just so satisfying to watch. But then again, maybe that's just machining in general. With all the slots opened up, I'll make one last operation before moving on and drop a chamfer on all these. This is good to do now during this setup since I can just retrace the paths of the milled slots from before and all the chamfers will come out consistently. Now I can move this whole setup over to the surface grinder for final finishing. My thinking is that since this 246 block is almost perfectly square, I can mount it right to the mag chuck. Then grinding the top face of the angle plate should bring it in square to the block and in turn square to itself. I'll add one more bolt to the setup just for a little extra support. And while I was considering adding some sort of jack bolt under the free hanging end, I don't really want to put anything in that could throw this setup out of whack. So I'll leave it be for now and revisit if I see any issues. The first pass has revealed just how poorly that fly cutting job went. Not only is the surface uneven, but it seems to be even less square than I started with. To burn down through this mess, I'll take half thou passes at 200 thou steps. Once I've cleared the whole face, I'll drop down to a couple 1/10 passes at 50 thou steps. Then to ensure the deflection isn't messing with me, I'll take a final spring pass at the same depth setting. Judging by the consistency of the sparks across the face, it doesn't seem like there's any deflection in the face whatsoever. Just as a sanity check, I'll break this down and check the squareness with the unground face. Only 2/10. I think it's safe to say there's probably no deflection. Moving on, I'll set up the freshly ground face against the 246 block and get this situated in the mill just like before. I think it goes without saying that I'll skip that show of a fly cutting stunt this time around and jump right to the milling. The pattern of the slots on this face is obviously different, but the process is the same. Mill the center line and then take a clearance pass along each side. Now that looks mostly good, except for a little train wreck going on over in this general area. Some of the starting slots on this face were all out of whack from the rest, so I sort of expected this to look bad, but not quite this bad. I could mill only the wonky slots wider, but then everything would probably look even worse. I think the only way around this is to jump up to a 5/8 end mill and widen all of the slots. I'll have to respace the center lines a bit from the original, but that's all arbitrary anyway. Now that looks a lot better. I'll drop some chamfers on here just like we did before, then set this up on the surface grinder for finishing passes and hopefully bring this face in perfectly square to the other. Let's break this down and see how it turned out. Well, I can hardly believe my eyes. Basically the whole face is within 1/10. I fully expected to have to use the step method to get this face square, but it looks like my efforts grinding the 246 block paid off. The last step on this angle plate is to grind the remaining edges square. 2 of these edges are pretty straightforward, as I can just mount the soldered faces down and grind the tops parallel. The side edges require a little more work though, as I want them to be square as well. Laying the angle plate on its side, I can use the comparator from each direction to see how far off I'm starting. Fortunately, it looks like I'm bang on in one direction and only 3/10 in the other. So I'll use the step method from before and grind a step in the correct location. Then I can flip this over and grind everything in square. And with that, the angle plate is complete. We could ooh and ah at how cool it looks, and I definitely did, but I cleaned it up for a specific purpose. This is a sine plate I made in a previous video. I spent many hours grinding all the faces square and flat. All the faces except for the ends. But I have a good excuse for this. Let me break this down real quick and I'll explain. I need to grind each end of each of the plates, but as you can see there's not really enough clearance on the surface grinder with the mag chuck in place. I needed a different setup. Now that I have this angle plate, I can remove the mag chuck to gain the clearance. I can mount the sine plate plates to the angle plate using the surface plate to indicate it in, and then mount this all directly to the surface grinder table base plate. Try saying that sentence 3 times fast. The only thing now I need is some hardware to hold the sine plate plates to the angle plate. So let's take a step back and whip up some quick clamping straps. These should do the trick. I'll use these in combination with my standard work holding hardware to clamp the first plate to the angle plate face. This makes the plate perfectly square in one direction, but there's still the other direction to consider. The squareness comparator would be the ideal tool for indicating this in vertical, but all the hardware down near the bottom prevents me from using this. Or does it? Turns out I just need a little boost. Look at that, the 246 block coming in handy once again. With the sine plate tapped in vertically, I can tighten everything down and move this whole setup over to the surface grinder and mount it to the table plate. And just to make sure nothing moved on me, it doesn't hurt to double check with the squareness comparator one last time. Still bang on. Actually, I might just square the next cuts right here on the machine rather than lug this all back over to the surface plate. Once I start taking passes, it's apparent how skewed the ends of the plates actually were. But it doesn't take long to get down past the slanted end to make it look like it actually belongs on this plate. I'll loosen my setup, flip the part end for end, indicate it in square with the surface gauge, and then start grinding all over again. Working my way through the other plate ends, I actually realized something silly that you may have already been thinking. Why didn't I just use the 246 block as an angle plate to hold my parts? You ever hear that saying, you can't see the forest for the trees? Well, consider me completely blind. The 246 block would have worked just as well here, if not better. But I suppose on the bright side now I have options. And I like options. Plus now the ends of my sine plate plates are perfectly square. Sure, I ended up doing a little more work than I probably needed to. It's hard to say it was a waste though, when not only did I fix some issues on a past project, but also brought life back to a couple other useful tools along the way. And even made a few new things I'm sure I'll use in the future. As always, thanks for watching, and see you next time.